combination of inventions and data. So part 202 is line 18M, noble gas compounds, B plus decay emission transport gas, 5G Wow Seti. There's the alien radio signal. And we're going to Google keywords from Wikipedia. Noble gas compounds are chemical compounds that include an element from group 18 of the periodic table of the noble gases. So we have transportation of AR, KR, and XE, noble gas compounds, whole transport gas, Ne, AR, KR, XE, neutrinos, B plus decay positron emission. So first we're going to Google the compound gas from the book. And up comes this one. Whole transport in the rare gas solids Ne, AR, KR, and XE. And that's from 1974. This paper reports an investigation of the drift mobility of excess holes in solid Ne, AR, KR, and XE. Thin crystal specimens, 500 to 500 50 to 500 UM thick, were grown from the liquid between parallel plate electrodes in a chamber attached to a miniature cryostat after purification of the starting gas. As in previous work on the electron transport in rare gas solids and liquids, an electron beam technique was used to generate excess carriers near one of the electrodes. Holes were extracted by the applied field and their transit time was measured directly, leading to the drift mobility. Close to the triple points, values in the above crystal lies between 1 and 10 to the 2, and those are the things there. Several orders of magnitude lower than the corresponding electron mobilities. The form of the temperature dependence of U changes progressively from XE in there to an essentially activated mobility in AR and NE. The experimental results have been analyzed in terms of small polarine theory using both the adiabatic and non-adiabatic approximations. The theory can account for the different forms of the temperature dependence and possible ranges of values for the predominant phonon energy. The polaron binding energy and the transfer energy for holes have been deduced in each case. These quantities characterizing the hole hopping transport vary systematically from XE to NE, and the correlation is discussed in some detail. That's from 1975. So our keywords here is the form of the temperature dependence of UH changes progressively from XE, U, and whatever that is, to an essentially activated mobility in AR and NE. So cold matter equals neutrinos is what to use for the dark matter. So I'm going to Google mobility in AR and NE, and up comes this journal here. Mobility of HE plus, NE plus, AR plus, N2 plus, O2 plus, and CO2 plus in their parent gas. Abstract is from E. Basurto, J. de Urquijo, L. Alvarez, and C. Cisneros from September 1999, dated March 2000. Okay, we have used a drift tube with double mass spectrometry to measure the mobility of He plus Ne plus AR plus N2 plus O2 plus CO2 and in their parent gas over a wide range of the density normalized electric field En from 70 to 12,500 times 10 minus 21 V M2. In all cases, the En ranges have exceeded those hitherto found in the literature, especially those of AR plus in AR and N2 plus in N2. Our mobility data are in fair to excellent agreement with previous experimental data in the overlap range. Recent calculated data for the mobility of AR plus in AR show excellent agreement with our data at high E-N, while fair agreement was observed for the calculated data of the systems N2 plus in N2 and O2 plus in O2. Also, the AR in the AR mobilities for En greater than 10K TD were found in excellent agreement with those derived from the measurement of the mean ion energy. In diffuse Townsend discharges, 1 TD equals 1 Townsend equals 10 minus 21 V M2. To the best of our knowledge, over some En ranges, our data were found to be the first to be reported. Okay, so that's correspondence goes to that address there if you have questions. pre.aps.org is the website. So then I Google the 10K TD to find out what it is, and this came up, Vichy Siliconox. Heavy duty high voltage capacitors from old datasheet system. And then we got quotes and diagrams in Wiki. Noble gas compound. Cleft rates have been used for separation of HE and NE from AR, KR, and XE, and also for the transportation of AR, KR, and XE. In addition, 85 KR cleft rate provides a safe source of beta particles, while 133 XE cleft rate provides a useful source of gamma rays. Noble gas atoms such as KR and XE can appear as guessing crystals of a melanophyllite. Here's beta decay. That's what it looks like. February 1st, 2012. I was working on this lens, and now it's April 27th. So my thoughts. Question. You say the neutrinos have decay while traveling at the speed of light. Is beta or B plus decay positron emission the answer to that? Quotes from Wiki. Beta particles are high energy, high speed electrons or positrons emitted by certain types of radioactive nuclei such as potassium 40, -40. The beta particles emitted are a form of ionizing radiation, also known as beta rays. The production of a beta particles is termed beta decay. They are designated by the Greek letters beta B. There are two forms of beta decay, B- and B+, which respectively give rise to the electron and the positron. B plus decay positron emission. Unstable atomic nuclei with an excess of protons may undergo B plus decay, also called positron decay, where a proton is converted into a neutron. A positron is an electron type neutrino, so P to N plus E plus V and E. Beta plus decay can only happen inside nuclei when the absolute value of the binding energy of the daughter nucleus is higher than that of the mother nucleus. At the atomic level, the atomic binding energy of the atom derives from electromagnetic interaction and is the energy required to disassemble an atom into free electrons in a nucleus. Electron binding energy is a measure of the energy required to free electrons from their atomic orbits. This is more commonly known as ionization energy. Binding energy. At the nuclear level, binding energy is also equal to the energy liberated when a nucleus is created from other nucleons or nuclei. This nuclear binding energy of nucleons into nuclide, is derived from the strong nuclear force and is the energy required to disassemble a nucleus into the same number of free unbound neutrons and protons it is composed of, so that the nucleons are far distant enough from each other so that the strong nuclear force can no longer cause the particles to interact. In astrophysics, gravitational binding energy of a celestial body is the energy required to expand the material to infinity. This quantity is not to be confused with the gravitational potential energy, which is the energy required to separate two bodies, such as a celestial body and a satellite, to infinite distance, keeping each intact. The latter energy is lower. In bound systems, if the binding energy is removed from the system, it must be subtracted from the mass of the unbound system, simply because this energy has mass, and if subtracted from the system at the time it is bound, will result in removal of mass from the system. System mass is not conserved in this process because the system is not closed during the binding process. Since all forms of energy exhibit rest mass within systems at rest, that is, systems which have no net momentum, the question of where the missing mass of the binding energy goes is of interest. The answer is that this mass isn't lost from a system which is not closed. It transforms to heat, light, higher energy states of the nucleus atom or other form of energy, but these types of energy also have mass, and it is necessary that they be removed from the system before its mass may decrease. The mass deficit from binding energy is therefore removed, mass that corresponds with removed energy, according to Einstein's equation E equals mc squared. Once the system cools to normal temperatures and returns to ground states in terms of energy levels, there is less mass remaining in the system than there was when it first combined and was at high energy. Mass measurements are almost always made at low temperatures. with systems and ground states, and this difference between the mass of a system and the sum of the masses of isolated parts is called a mass deficit. Thus, if binding energy mass is transformed into heat, the system must be cooled, the heat removed before the mass deficit appears in the cooled system. In that case, the removed heat represents exactly the mass deficit, and the heat itself retains the mass which was lost from the point of view of the initial system. This mass appears in the other system, which absorbs the heat and gains thermal energy. As an illustration, let's consider two objects attracting each other in space through their gravitational field. Now, I've been talking about that with asteroids. When a CME ejects off the sun and goes away from Earth, it actually bounces the matter that's out there, and it affects Earth in a roundabout way. I haven't proved it yet, but I'm trying to. The attraction force accelerates the objects, and they gain some speed toward each other, converting the potential gravity energy into kinetic movement energy. When either the particles pass through each other without interaction or elastically repelled during the collision, the gained kinetic energy related to speed starts to revert into potential form, driving the collided particles apart. The decelerating particles will return to the initial distance and beyond into infinity or stop and repeat the collision. Oscillation takes place. This shows that the system which loses no energy does not bind into a solid objects, part of which oscillate at short distances. Therefore, in order to bind the particles, the kinetic energy gained due to the attraction must be dissipated by a resistive force. Sorry, I'm getting dry mouth here. Complex objects in collision ordinarily undergo inelastic collision, transforming some kinetic energy into internal energy, heat content, which is atomic movement, which is further radiated in the form of photons, the light and heat. Once the energy to escape the gravity is dissipated in the collision, the parts will oscillate at closer, possibly atomic distance, thus looking like one solid object. This lost energy necessary to overcome the potential barrier in order to separate the objects is the binding energy. If this binding energy were retained in the system as heat, its mass would not decrease. However, binding energy lost from the system as heat radiation would itself have mass and directly represent the mass deficit of the cold bound system. Closely analogous considerations apply in chemical and nuclear considerations. Exothermic chemical reactions in closed systems do not change mass, but in theory become less massive once the heat of reaction is removed. This mass change is too small to measure with standard equipment. In nuclear reactions, however, the fraction of mass that may be removed as light or heat, i.e. binding energy, is often a much larger fraction of the system mass. It may thus be measured directly as a mass difference between rest masses of reactants and products. This is because nuclear forces are comparatively stronger than Coulombic forces associated with the interactions between electrons and protons that generate heat in chemistry. So, my thoughts continue. We got a formula here. We have a formula idea. We're going to take binding energy and we're going to add some neutrinos to it. I'm going to see the quote below. Is this in relation to how neutrinos work? As an illustration, consider two objects attracting each other in space through their gravitational field. The attraction force accelerates the objects and they gain some speed toward each other, converting the potential gravity energy into kinetic movement energy when either the particles pass through each other without interaction, which would be the neutrinos, because they can go through other particles, or they can elastically repel during the collision and gain kinetic energy. Complex object collision under inelastic collision, transferring some kinetic energy into internal energy. Heat content, which is atomic movement, which is further radiated in the form of photons, the light and heat. Once the energy to escape the gravity is dissipated in the collision, the parts will oscillate at closer, possibly atomic distance, thus looking like one solid object. This lost energy necessary to overcome the potential barrier in order to separate the objects is the binding energy. If this binding energy were retained in the system as heat, its mass would not decrease. However, binding energy lost from the system as heat radiation would itself have mass and directly represent the mass deficit of the cold bound system. So that's the end of that video.